Good morning, ladies and gentlemen. Welcome back. We're going to take a look at a couple of warm-up questions related to trigonometry. The warm-up was as follows. There are 3 questions here. You might want to pause the video and try it yourself. But really quickly, to show us in class, we're going to rewrite the questions in terms of sine and cosine if we can. And then we're going to try to simplify it also if we can. So these kind of questions, these actually have answers. These are not identities. Okay? So in the first question we have is cosine theta times secant theta. And notice, none of the angles are provided, right? They always have to be for a specific question, right? And this kind of questions are just to help us with our proofs. So if you want to pause the video now before I start doing the answers, you can. But for the people that are here in class, let's continue. Cosine theta times secant theta. What you're using as a tool set, and again, you probably can't see this at home, but I've written out all the trigonometric identities here. So when you're doing your assignment at home, or even when you're following along, I encourage you, have your tool set or your rules beside you when you're solving. These are basically our proof or our evidence that we're going to show what we're going to do. And so for the first step, for cosine theta times secant theta, well, cosine theta is already in cosine, so that's kind of the tip that I'm trying to emphasize. But I can rewrite secant theta. Secant theta, using the reciprocal identity, is 1 over cos squared. And so that would be the first step to rewrite things in terms of sine and cosine. That is actually the best strategy that we're trying to show you. But a lot of you actually can see in this particular question, this one actually simplifies to 1. And so this is the answer for this question. If you really wanted to test it out, again, we don't have a calculator, but if you said the cosine of 20 degrees times the secant of 20 degrees, believe it or not, that should be 1. Okay? But we're not going to do it actual numbers. And that's what the kind of neat things about identities. Question B, it says 1 plus sine squared theta times 1 minus sine squared theta. I think for the class here, you can already tell this question looks like the difference of squares. So notice there's some algebra here, expanding and factoring. But this particular case, this is actually a difference of squares. So I'm not going to change the ones. I'm actually just going to ignore this first step. Oops. And we get 1 minus sine squared theta. Now what's really, really interesting about this one, there's a couple ways of doing this particular problem. That's not right. I think I might have copied the question wrong. Okay, so I think this is a typo. I think this is supposed to be this. That's my fault. I think it's supposed to be this. Sorry, let's read the question again. Sorry. Question B, 1 plus sine theta times 1 minus sine theta is 1 minus sine squared theta. Sorry, that's what I wanted. I'm getting old. So 1 minus sine squared theta. And so what I'm going to do here is replace this 1 with one of the Pythagorean identities. And this is the Pythagorean identity which I haven't really proven to you yet, but we'll do it hopefully in class today to show. So that 1 is going to be replaced with sine squared theta plus cos squared theta minus sine squared theta. And then of course these subtract, so these two subtract, and what are we left with? Cos squared theta. So what I'm trying to share with you, ladies and gentlemen, is that they're kind of like puzzles. Puzzles. Let's try the last one, question C. And again, hopefully that'll work. For question C, we have 1 plus cotangent x over cosecant x. So the first tip is to change things in terms of sine and cosine. So I'm going to leave that 1 alone for right now. But cotangent x, using the quotient identity, I'm not going to use 1 over tan theta. 1 over tan x, I rarely ever use that. But sometimes it is a tip to use. And so for this one, 1 plus cotangent x, I think everyone agrees it's going to be cos x over sin x all over 1 over sin x. And again, everything's in terms of sine and cosine, so that's great. How do we add fractions? Well, we have to get a common denominator. So let's just take an extra step to show what was happening. 1 is going to change to sine x over sin x. And again, this is not the only way to do this question, but that's what we get. I'm running out of room, so let's put that up there. So what we have is sine x plus cos x over sine x. And division means to multiply by the reciprocal, right? Therefore, these two divide out. And that's the answer. Sine x plus cos x. Let's just pause the video there. Hopefully, people saw that.